Hello everyone, welcome to my Science Cafe. Today we are going to learn how to identify groups period block of an element. For this purpose, we need to perform electronic configuration. But this time we are doing electronic configuration basis on the orbitals, subshells, not on the basis of orbits. Remember that. And I hope this lecture is for second year students, and I hope that they know the difference between the orbitals and orbits. And if you are not good at electronic configuration of orbitals, I will be doing another lecture on Aufbau principle, N plus L rule, Hertz rule, which will give us brief information about how this sequence has been achieved. But for the time being, you have to learn the order of orbitals for the electronic configuration. Now, without any further ado, let's jump to our lecture. Now class, first of all, I need you to learn the order of orbitals. In this way, we can perform electronic configuration. You have to learn this order: 1s2, 2s2, 2p6, 3s2 till 5p6. It contains almost elements up to 54 atomic number, and I hope it will summarize the topic, and all the elements in your examination will be under this electronic configuration. It will be enough. Now, for brief introduction about the topic, s orbital contains 2 electrons, p orbital contains 6 electrons, and d orbital contains 10 electrons. Here it is written here s2 and p6 and d10. If you want to understand k shell, l shell, if you want to understand orbitals in terms of orbits, then k shell contains 1s2, l shell contains 2s2 and 2p6, as 2 plus 6 will give you 8 electrons, and m shell contains 2, 6, 8, 8 and 10, 18 electrons in its orbit. First of all, let's do an example so that it will be cleared in our mind. We are taking sodium as an example. Sodium's atomic number is 11. Now to perform electronic configuration, here we need to write electronic configuration till all the 11 electrons are covered in it. So we will write from 1s2, 2s2, 2p6, 3s2, but here we have to understand that 2 plus 2 4 and 10 plus 2 12, and we need 11 electrons, so we will write 3s1, 1s2, 2s2, 2p6, 3s1. If you want to count the electrons, 2 plus 2 4, 4 plus 6 10, and 10 plus 1 11. Here electronic configuration has been done. Now to predict the period, the highest coefficient in the electronic configuration is your period. So what I am calling the coefficient is, I am taking the orbitals as variable. So the number associated with all the variables are coefficient, and the highest coefficient in this electronic configuration is 3. So our period is 3. We can write it as P is equal to 3 for sodium. To identify period is very easy. Now we are going to jump on group. Group, there is a complexity in determining and prediction of groups. So to understand, we have to understand by step, taking s orbital into account, then p, then d. First of all those elements whose electronic configuration ends at s orbital, like the example of sodium. Here our electronic configuration ends at s orbital. So it is easy, just note the number of electron on the s orbital. Here we have 1, and this is our group number. It's that easy. If your element ends at s orbital, just note down the number of electron written above the s orbital. That will be your group number. So where we have group, we can write G is equal to 1. But we have to understand, either we have to write 1A or 1B. Remember, for A and S, for S and P, we will write A. So our group will be 1A. Now guys, if you are wondering where this A comes from, this A represents that it is a representative element. Sodium is a representative element, and B represents, it's a transition element. You have already seen that group 1A, 1B, 2A, 2B. So A represents, the element belongs to a representative element, and B represents, it belongs to a transition element. For all those electronic configuration that ends at either S or P, you will write A in its group, and A represents representative element. I hope it's clear. For D and F we will write B. Now let's take a look on another example. Now we will take example of chromium. Its atomic number is 24. Now again let's do the electronic configuration. We need 24 electrons. 2, 4, 10, 12, 18, 20 and D4 will give you 24, starting from 1s2, 2s2, 2p6, 3s2, 3p6, 4s2 and 3d4. You can double check it. Electronic configuration. So we have done the electronic configuration. Again, to remind the period, the highest coefficient in your electronic configuration, you can see 4 here. 4 is the highest coefficient. So our period is 4th. Now to remind the group, this electronic configuration does not end at s orbital, rather it ends at d orbital. So whenever your group, your electronic configuration ends at d orbital, you need to add 2 electrons on the already present number of electrons on the power. Here we have 4 electrons. Our electronic configuration ends at D4, but to determine the group we need to add plus 2, and 4 plus 2 gives you 6. This shows that chromium belongs to group 6. But remember, 6A or 6B, we will write 6B, because for D, all those elements whose electronic configuration ends at d orbital, they belong to transition element, and B represents transition element. So we have done somewhat almost important things in the identification, but remember, if your group ends at 7, what will you do? 7 plus 2 will give you 9. If your element whose electronic configuration ends at D7, and then you will add 2 and it will become 9, and 9 does not exist. Only we have groups till 8. What will we be doing then? To know, stay tuned. We will be doing it in the next lecture. Furthermore examples like D6, D7, D8 and some important points, and then we will be doing another lecture on valency, how to identify the valency of a particular element. An important thing is here, block. If you need to determine which element belongs to which block, so chromium belongs to block D. The orbital on which the electronic configuration ends gives you block number. It's a D block element. So how can you identify the block? Block will be identified easily. The electronic configuration ends at the block will be the block of that element. Simple. In the example of, we did the last example of sodium, and sodium ends at S, so sodium belongs to S block. S block. Here you can identify the blocks. Thank you very much. See you in the next lecture.